Hello everyone. I have created this electrical protection course in such a way that it is accessible to everyone, including people without any electrical background. As you know, electrical protection is a key element in all the electrical systems and ensures that the electrical network can operate safely and efficiently. I have started a series of this course, and this is the first lecture on the protection system. In this course and in this lecture particularly, I will introduce all the basic principles of the protection system, and I would try that at the end of the course you have a good theoretical and practical knowledge of the electrical protection system. So stay tuned till the end of the course. So first I will go to the second slide. So the first equipment in the electrical system is the power source. It could be a power station, a diesel generator, a wind turbine, a solar system, or any hydropower system. Then at the end we have a load. It can be a motor, it can be any factory or anything. And we connect the power source with the load with the help of the transmission line. So below you can see a typical and a very simple example of the source and the load. So in this slide I will introduce some of the pictures of the equipment that belongs to the primary, secondary and auxiliary equipment, and I have mentioned just roughly. Now you have to tell me that in these pictures how much you understand them and to which part they belong to. So here we have, you have to tell me what is this one, all these parts, and at the end of the lecture I will give you the answers, but this mm, quiz is only just to understand your own knowledge. Okay, now let's go further. First we have the measurement equipment. This symbol is the current transformer. These transform the thousands of amperes on the primary system into a lower current level so it can be used by the protection system. Then we have voltage transformers. These are the two symbols we use for the voltage transformer, and these transforms the high voltage found on a primary system into a lower voltage levels. Then we have a protection, the protection panels. Then we have a control system. In control system we have SCADA system, then the primary plant, and then we have our equipment. I will show you the primary network and the secondary side, how it works. So if you see the downside here, this is the circuit breakers which are widely used throughout the system to switch the electricity on and off. So we have three conditions of this circuit breaker. One is when the breaker is closed, and if something goes wrong, then the circuit breaker is tripped by an electrical protection system and it open the system upstream and downstream. Here next is the symbol that we use for the protection relays. The number or symbol inside the rectangle indicates the type of relay as per international standards. So next is our the primary equipment. As you remember, I gave you a quiz of primary, secondary, and auxiliary equipment. So the first one is the primary equipment, and it is defined as everything that is directly connected to the system voltage. This includes substation equipment such as circuit breaker, isolators, and current transformers. If we talk about the transformers, these change the system voltage from a very high level to a low level. And finally, we have a load, and in this case, I indicate it as a motor or a washing machine that use up the electrical energy of the system. If you see this blue, black, brown, and red, these are the bus bars, indication of bus bars, cables, or overhead lines that takes the electricity around the system from the source to the load side. Then we have the secondary equipment. Secondary equipment is defined as the systems and equipments that control, monitor, and protect the primary system. So secondary system is basically the protection of the primary system. And in the secondary equipment we have protection relay, our SCADA system, and then we have the auxiliary system. So in the protection system we have a numerous separate elements that work together. These includes circuit breakers, protection system, including circuit breaker control, where we open and close the circuit breaker via its operating mechanism. Circuit breaker protection, where we protect the integrity of the protection circuit breaker, this relay, and synchronizing them, where we ensure that the circuit breaker only closes when it's safe to do so. In the next lectures, I will explain how we will make sure and how the protection relay will operate to open the circuit breaker. Beside the relay, we have a protection system itself. These include auxiliary relays that repeat signals and pass them on to the other system. And then we have the trip relays that open the circuit breaker when a fault occurs. And finally, a protection relay. These continuously monitor the currents and voltages and make sure that the system is healthy. Finally, we have auxiliary system, which includes the batteries and the auxiliary system that controls the battery system. So if you see, we have the three sections: the measurement section, then the protection section, and the primary plant. So I was telling you about the control system. We have equipment operation system that allows you to remotely open and close all of the primary equipment. We have indication system that show the position of all the circuit breakers, disconnectors, and other primary equipment. And that indication is this one. If you see this one, this is the indication of all the opening and closing of the circuit breakers. Similarly, we have alarm signaling. These tell the operators when something's gone wrong on the system. Let's now see the measurement, production, and primary plant equipment. Sorry, I came to this slide before, but I thought I have to explain you some previous slides and then I come back again here. First, in this slide, we have the measuring equipment. This contains current transformer, as you can see, to provide information on the primary current. Then we have voltage transformers to provide the information on the primary voltage. Then we have protection equipment containing protection panels, relays and systems. Control equipment containing MMIC control panel and SCADA system. And finally the primary plant such as the circuit breaker. The current transformer feed current information into the protection system and the control system, and likewise the voltage transformer provides voltage information to these two systems, to the protection and the control system. Then what control system do? The control system send signals to open and close the primary plant, and we then get status signal back from the primary plant to the protection and control equipment. Finally, when something goes wrong, the protection system sends trip signal to open the circuit breaker in an emergency. The actual interaction between the measurement, protection, control and primary plant system are obviously unique to each substation, but it's clear that all four systems work as one complete system. The complexity of these connections increase as the system voltage increase. For example, if we use high voltage system, medium voltage system and low voltage system, these three are the different voltage types. With the distribution system having very simple protection and control system, while high voltage substations have multiple layer of protection and several points of control. If you think about the previous slide, then the one that I did not talk about is the auxiliary system that I did not talk much about. This basically sit in the background to keep the protection and control system working. So here in the next slide, if you see, we have a primary network, low voltage, AC-DC converter and battery. I will explain each and every part just for a very basic overview. Firstly, we have the station service transformer, this one, the two holes. This transforms the voltage from primary system into a low voltage that we can feed into all the panels. We have the low voltage AC supply boards as well. In this low voltage, these supply the low voltage to the protection and the control system. Finally, we have the direct current or DC battery charger system. All substation needs a backup. That's why we use battery energy system. In case if the primary main system fails, then we can use this battery setup. Now let's see how the auxiliary system fit together. First, we have the station service transformer connecting the primary voltage, let's say 33 kV, to the low voltage, let's say 400 volts, just for as an example, system. This system then feeds auxiliary supplies including spring charging and panel lighting to the primary plant and protection and control system. The low voltage system also feeds an AC to DC converter which feeds the DC distribution board. This feeds the local control signals and the protection and control supplies to the protection control system. And finally, we have a battery. This is there to provide emergency supplies in case the primary network fails. Most high voltage substations have a battery that can provide a DC supply for up to 8 hours after the primary network has failed. This allows you to open and close the breaker and monitor the system until the supply from the main primary network returns. So here is basically the end of our lecture. Let's summarize very quickly what we have learned today. We learned about the secondary equipment, and it is defined as the system and equipment that control, monitor and protect the primary system. A substation protection system consists of measuring equipment, protection equipment and control equipment and auxiliary system. Then auxiliary system are provided to supply AC and DC to the protection of control system. This is the end of the first lecture. This is my first ever lecture on YouTube, so if there are some mistakes, I will try to rectify in my coming lectures. And if you believe you have learned something out of this lecture, please don't forget to subscribe and share. And stay tuned. In the next lectures, I will go into very detailed topic. Thank you so much.